Hello. Hello, good afternoon.
Good afternoon, sir.
Okay. Whether the screen is visible to all? The screen is visible? Okay. Okay, Prajwal. We will wait for a while because still many students are not join our lecture. Omkar, mute your video. In last lecture, we are taking a recap over the our subject, that is industrial hydraulics and pneumatics as per the syllabus. In first section, we study three chapters, which is a focus on hydraulics, and in second section, we study next three chapters, which will focus on pneumatics. As far as first chapter is concerned, introduction to hydraulic system and hydraulic actuators. One part is remaining, I think, that will be related to the calculation of force and the velocity of the piston in case of the hydraulic pump, right? That we will cover during this lecture. It will be from chapter number second, sorry. Pumps, accumulator, valves, and intensifier, where we study different type of the pump, its construction, its working, its application, and characteristics. This part is remaining, right? The calculation of force and velocity. From the NPTL, I have taken some examples, which is based or somewhat focused on force and velocity of the piston. That example we will discuss and solve during this lecture. This is the calculation of force and velocity of the piston. There will be first example, that is a hydraulic pump that will supply an oil of 0.002 meter cube per second. There will be one hydraulic pump which will supply the 0.002 meter cube per second. So meter cube second, it is a unit of a discharge. To a 50 mm diameter double acting cylinder. The 50 mm diameter, that is the outer diameter of the piston, at the same time that will be the inner diameter of the cylinder, that is the 50 mm. And a rod diameter, which rod? That is piston rod, is of a 20 mm diameter. Whatever the 20 mm, it is the diameter of the piston. If the load of 6,000 Newton, both in extending and retracting, is to be applied. Then you have to find these three parameters. Means that when we are applying a load, or it may be called as a force of 6,000 Newton during the extension stroke of the piston as well as during the retraction stroke of the piston. You have to find first piston velocity during the extension stroke and retraction stroke. We are only focusing related to the piston velocity, but these are the certain parameters related to the pressure, related to the power. As it is a part of this example, we also focus on how to calculate the pressure that will be exerted during the extension and retraction stroke of the piston. At the same time, how much is the power is to be required during this extension and retraction stroke of the piston. So when you are reading this example, right, we are getting the data like there will be one hydraulic pump, right, which is utilized to supply the hydraulic oil with some discharge. It is a 0.02 meter cube per second. So oil flow rate, if you are starting the solution for it, then what is the given data? Oil flow rate from the pump, that is a Q. Whenever you are observing this, whenever you are observing this value, by considering this unit, we will be able to judge what is the unit for that, for which this unit is there, for which quantity this unit is there, right? So meter cube per second, this is the unit for the discharge, right? कुठला पॅरामीटर आहे, कुठलं डायमेन्शन आहे की ज्याचं युनिट मीटर क्यूब सेकंद आहे. So we will easily identify that they are given the discharge 0.02 meter cube per second. So diameter of a double acting cylinder. So it will be diameter of the cylinder. It is given how much? 50 mm. Convert it into meter. And the rod diameter, that is a 20 mm. It is related to the piston rod diameter 20 mm. Convert it into meter. And they have to ask piston velocity, pressure and power during extension and retraction stroke for the load which is having a value of 600 Newton, that is a force, 600 Newton, that is a force during extension and retracting condition or stroke. So this is the example, and this will be the given data when you are reading this example or understanding this example, and you have to find out the piston velocity, pressure and power during the extension stroke. Are you understand what parameters are given in this example and which parameter you have to find out? Hello? Hello? हेलो दीप ज्योति, एग्जाम्पल समझ ले?
यस सर.
कंटाळत का काय आज सगळे? भारत, आर यू देयर? भारत,
Yes, sir.
एक्झाम्पल डिस्क्रिप्शन आणि त्याचा गिवन डेटा समजला का? सुनील, सुनील, आर यू देयर? सुनील?
Yes, sir.
Okay. Then write down the description, that is statement of the or problem, its finding and given data. Then we will go for the how to calculate piston velocity, how to calculate the pressure and how to calculate the power. write the example and start the solution with the given data. Hello.
Yes, sir.
Have you written the example or not?
Written, sir.
Okay. This is the description for the pump that was delivering certain amount of oil, right? And uh, given the value of the cylinder diameter and piston rod, we have to calculate the piston velocity, pressure exerted, and power during the extension and retraction stroke for the load of 6000 Newton. Now, we'll start with the first, that is the piston velocity during the extension stroke, right? The piston velocity, it is calculated by formula V. For the velocity, we use the letter V, and during the extension stroke, suffix E, it is equal to Q upon A, right? Q is the discharge. Area of the piston or area of the cylinder, it will be the same. So Q, you know, it is the 0.02 meter cube per second. And area, that is the pi by 4 d square, where you have to consider the diameter of the cylinder. So you are getting the piston velocity during extension stroke, that is a, if you are calculating this amount, it will be 1 meter per second. Now, we can also calculate the piston velocity during the retraction stroke. For retraction stroke, there will be a formula VR is equal to Q. Q is nothing but the discharge divided by AP minus AR, where area of piston or area of cylinder, through which you have to subtract the area of piston rod, AR for the area of the piston rod. So you know that Q, its value is 0.002 divided by pi by 4. Area we can calculate pi by 4 d square. So pi by 4 area of the piston or cylinder, that is 0.05. 0.05 diameter of the cylinder, right? And diameter of the piston rod, AR, its value is the diameter of the rod 0.02. So you can calculate the piston velocity during extension by formula V is equal to Q upon AP. Why we are not considering AR? Because during the extension stroke, we are pushing the piston in outward direction, and it is a we are supplying the fluid on a piston head side, right? And during the retraction stroke, you are supplying the fluid or oil towards the rod end side. म्हणजे पहा, जेव्हा पिस्टन बाहेरच्या बाजूला ढकलला जातो तेव्हा पिस्टनच्या हेड कडल्या बाजूने आपण ऑइल सप्लाय करतो, म्हणजे कम्प्लीट एरिया, इनर एरिया ऑफ द सिलेंडर आपल्याला मिळतो, बरोबर आहे का? आणि जेव्हा रिट्रॅक्शन स्ट्रोक आपण स्टार्ट करतो, जर आपण डायग्राम काढली, हा सिलेंडर आहे, हा पिस्टन आहे आणि हा पिस्टन रॉड आहे, बरोबर? जेव्हा पिस्टन राईट हँडला मूव्ह होतो तेव्हा काय होतो? एक्सटेन्शन. आणि जेव्हा पिस्टन लेफ्ट हँडला मूव्ह होतो तेव्हा तुमचा स्ट्रोक कुठला आहे? रिट्रॅक्शन. एक्सटेन्शन स्ट्रोकच्या वेळेस आपण इथं फ्लुइड सप्लाय करतो. वी आर सप्लाइंग द फ्लुइड ऑन हेड साइड ऑफ द पिस्टन. सो यू आर गेटिंग ओव्हरऑल एरिया ऑफ द सिलेंडर, राईट? हा सगळा एरिया तुम्हाला मिळतो. म्हणून आपण एरिया ऑफ द पिस्टन और inner area of the cylinder consider करू, राईट. आणि वेलोसिटी ड्युरिंग द रिट्रॅक्शन स्ट्रोक त्यावेळेस काय करतो आपण, हा जो एरिया आहे मायनस हा पिस्टन रॉडचा एरिया, हा त्याच्यातून मायनस करावा लागेल. हा एरिया आपल्याला एरिया ऑफ द पिस्टन रॉड हा एवढा मायनस होईल. मग राहिलेला एरिया कुठला असणार तुमचा राजांनो, हा एवढा एरिया, दिस मच अँड दिस मच, राईट. म्हणजे जेव्हा कम्प्लीट सिलेंडरच्या एरियामधून पिस्टन रॉडचा एरिया तुम्ही वजा कराल तेव्हा दॅट विल बी द एरिया फॉर द फ्लोइंग फ्लुइड ड्युरिंग द रिट्रॅक्शन स्ट्रोक. दॅट विल बी गिवन बाय दिस व्हॅल्यू, एरिया ऑफ द ओव्हरऑल सिलेंडर मायनस एरिया ऑफ द पिस्टन रॉड. इथपर्यंत काय अडचण समजतंय? हॅलो,
Yes,
आर यू
sir.
अंडरस्टूड?
Understood.
How to calculate the piston velocity during the extension stroke? Write down this first. Piston velocity, how to calculate during the extension stroke? Write this formula. And during the retraction stroke, write this formula. Complete the calculation up to this. Okay, you have calculated the piston velocity. Now, second point,
Yes, sir.
they are asking pressure during the extension stroke. Right? Now, how we will calculate the pressure? Pressure is nothing but the force upon area, right? Or load per unit area. Likewise, we can calculate the pressure. P for the pressure, E for extension stroke. So it is equal to F upon AP. AP is the area of the piston or cylinder. We can put the value. We know that what is the value of F? F is a 6,000. We are putting the value of F. It is 6,000 Newton. See the unit. Newton is there, right? And area of the piston pi by 4 d square. D is the diameter of the cylinder. Diameter of the cylinder, its value is a 0.05. We are putting over here pi by 4 d square. So you are getting the value when you are solving this. That is a Newton per meter square. That is bar. You are getting the value. Similarly, cylinder pressure during the retraction stroke. only area this value is changing, because during the retraction stroke you have to subtract this area of the piston rod from the area of the cylinder. When you are putting these values, you are getting the cylinder pressure as a 36.4 bar, because value of F there is a 6000, area is calculated by formula A is equal to 5 by 4 d square. Right. So first D it is for the cylinder, its value is a 0.05, and second D it is a for the piston rod, its value is 0.02. When you are solving, you are getting this value. So in this way, you can calculate the cylinder pressure during the extension stroke as well as during the retraction stroke. Complete this. Cylinder pressure during extension and retraction. Is it over? Up to pressure, cylinder pressure. Is it clear? Okay. Now next part, that is the cylinder power, and it will be calculated by formula pressure into discharge divided by 1000. You are calculate that the cylinder pressure E for extension, its value is 30.6. Now it is in a bar. Unit is a bar. We are converted into Pascal. That is 10 raised to 5. Right? And Q is the discharge. Its value is Q is the discharge. Its value is 0.002 meter cube per second. 0.002 meter cube per second divided by 1000. When you are simplifying, you are getting the power in terms of kilowatt, because we are dividing by 1000. For that, you are getting the power, that is 6.12 kilowatt during this extension stroke by using this formula. You can calculate the cylinder power during retraction by retraction. Are you understood? Because we are using PR. Here P for extension, PR for retraction. What is the value of PR? It is 36.4. 36.4 into 10 raised to 5. Converting bar to Pascal. Multiply by Q. What is the value of Q? 0.002. And convert this into kilowatt. You have to divide by 1000. So cylinder power during the retraction stroke is a 7.28 kilowatt. During the extension stroke, it is a 6.12 kilowatt. Are you understood how to calculate the power?
Yes, sir.
Okay. Write down these steps to calculating the power. Any problem? Is it over? Have you calculated cylinder power?
Yes, sir.
Okay. Any problem for this example? Any doubt?
Yes.
Okay. Okay, we will take the attendance. Roll number from the A division. Write your roll number in chat box. Is A division students are over? Okay. B division, start your roll number. Write your roll number in chat box. Today strength is very less because of network problem. What is the problem? स्ट्रेंथ का कमी आहे सकाळपासून एवढीच आहे का 20 हॅलो हॅलो
Yes, sir.
फ्रॉम मॉर्निंग स्ट्रेंथ इज लेस फॉर ऑल लेक्चर
Yes, sir. Only one lecture is conducted.
ओनली वन इज कंडक्टेड विच वन
Meta.
मेटा
Metallurgy.
okay because from last 2 days because of change in climate situations there will be electricity problem and range problem student as well as faculty also suffer lots for conducting the online lectures okay no problem then we will take another example have you understood this example
Yes, sir.
okay now second example a hydraulic cylinder has to move a table of weight 13 kilowatt okay means weight of force it is up to 13 kilowatt w value of w it is given right it is nothing but the value of w how much it is 13 kilowatt converted into kilonewton sorry it is in 13 kilonewton not watt you can convert into newton speed of the cylinder is to be accelerated up to a velocity of 0.13 meter per second accelerated म्हटले starting दिले का नाही end position दिली तुम्हाला so it is a final velocity it will be denoted by small v right it will be denoted by small v. Why it is a velocity because its unit is a meter per second in 0.5 seconds so second it is a value related to the time small t right and brought to stop with a distance of 0.02 मीटर डिस्टन्स म्हटलं मीटरचं युनिट काय लेंथचं युनिट मीटर आहे म्हणजे डिस्टन्स आपण लेंथ मध्ये कन्सिडर करतो आणि त्याचं युनिट मीटर मध्ये आहे इट इज द व्हॅल्यू ऑफ डिस्टन्स वी मे डिनोटेड बाय स्मॉल एस ओके इट इज अ स्मॉल एस assume coefficient of sliding friction this is the friction coefficient you may write by mu and cylinder bore diameter it is of a how much 50 mm cylinder bore diameter dile you may write by d capital cylinder bore diameter you have to calculate the surge pressure. Okay, and surge pressure it is calculated by PS. It is equal to P1 plus P2. And what is the P1? It is a pressure required in hydraulic cylinder to overcome the force. That is the P1. And what is the P2? Pressure created by the opposing force. Right? It is called as a P2. We'll see. Now see here. If you are reading this example carefully, you can able to write the given data. Right? Initial velocity u. We are considering initial velocity u because we know that the formula of acceleration a is equal to v minus u upon t. Final velocity, you know that it is a 0.13. Time, we know that it is a 0.5. And initial velocity, whereas it is a 0, initial state. So you are getting the acceleration, that is a 0.26 meter per second square. See the unit. Velocity unit is meter per second and acceleration is meter per second square. Right? First, you have to calculate the force required to move the piston. Piston move करण्यासाठी तुम्हाला काय कुठला फोर्स लागेल? It is the addition of dynamic force plus frictional force. Dynamic force it is calculated by this formula. That is the W divided by G into acceleration. What is the W? W is the weight. How much it is? 13 kilonewton converted into Newton. 13,000. G is the acceleration due to gravity, that is 9.81. What is the A? A is the initial acceleration. Its value is the 0.26. Right? Plus frictional force. How it will be calculated? Coefficient of friction multiplied by weight of the table. So how much is the value of coefficient of friction? That is 15. 0.15, sorry. Mu is the coefficient of friction. Its value is the 0.15. So frictional force it is calculated by this formula. And its value we are putting over here. Mu ची value किती आहे? 0.15 आणि W ची value किती आहे? 13 kilonewton म्हणजे काय? 13,000 Newton. When you are solving this, you are getting the value of the force required to move the piston. Right? आपण गेलेल्या एक्झाम्पल मध्ये काय पाहिलं आपण? वेलोसिटी पाहिली. ह्या एक्झाम्पल मध्ये एक पार्ट आहे तो आपण फोर्सचा इथं कव्हर केलेला आहे. पुढचा आपण बघूयात. पण जो काय आपला पार्ट होता कॅल्क्युलेशन ऑफ velocity of the piston and force exerted by the piston, force required to move the piston. हे दोन्ही पॅरामीटर आपण ह्या दोन एक्झाम्पलच्या सहाय्याने कव्हर केलेले आहेत. समजतंय का? फोर्स रिक्वायर्ड टू मूव द पिस्टन कसं कॅल्क्युलेट केलं आपण एक्झाम्पल मध्ये?
Yes, sir.
Okay. First of all, you write down the example, then given data, and calculate the force required to move the piston. The value of F, that is the 2294.5. Write down the example first. Start to write its solution initially by given data, then calculate acceleration and force required to move the piston. एक्झाम्पल समजण्यात काय अडचण आहे का? कुठला पॅरामीटर क्वांटिटी समजलं नाही असं आहे का?
No, sir.
ओके, राईट डाऊन. Is it over?
Yes, sir.
Okay. Then, whatever the force you have calculated to move the piston, it is a 2294.5 Newton. In order to overcome this force, we require certain amount of pressure, and pressure is calculated by formula force upon area. P is equal to force upon area. By this formula, you are calculating the pressure. Right? Force upon area. You know the value of the force F. F is equal to This will be the value of force. F is equal to 2294.5 upon area of the cylinder by considering the diameter of the bore diameter of the cylinder, that is the 550 mm. Convert it into meter. You are getting the value 0.05. That is the diameter of the bore diameter of the cylinder. So it will be 5 by 4 d square. When you are solving this, you are getting the value of the pressure in terms of bar. Also, there will be one equation which will correlate between velocity, acceleration, and distance. And that equation is given by this formula. V square minus C square is equal to 2AS. Final velocity, initial velocity, 2 into acceleration into distance covered. Yes is the distance covered. So during the retraction, V is the initial velocity and U is with the final velocity, right? So it is equal to 2AS. When you have to find out this A, value of A, at that time V square minus E square divided by 2S. This value of 2 and S, it will be goes on denominator side. So A can be calculated by this formula, V square minus U square divided by 2S. Now we are putting the value, you are getting the acceleration. It will be a minus 0.4225. Where this negative sign, it will be indicate deceleration. What it indicates? Deceleration. And last, you have to calculate the total force which will require to stop the motion of the cylinder. Right? सुरुवातीला काय पाहिलं आपण? Force required to move the piston पाहिलं. त्याच्यानंतर ह्या फोर्सला ओव्हरकम करण्यासाठी लागणारं प्रेशर काढलं आपण. त्याच्यानंतर ऍक्सेलरेशनची व्हॅल्यू काढली, ती आपल्याला मिळाली निगेटिव्ह. So it will indicate it is a deceleration. Now we are calculating the total force required to stop the motion of the cylinder. And its formula, that is a W by G into A plus mu into W. That will be taken over here. तर पाहिलंय आपण तो फॉर्म्युला, फोर्स रिक्वायर्ड. जसं मूव्ह करायला फोर्स लागणार आहे, पिस्टनला मूव्ह करायला, तसं स्टॉप करायला फोर्स लागणार आहे. हाच फॉर्म्युला मी काय केलंय पाठीमागच्या स्लाइड मध्ये इथे घेतला. फक्त आता व्हॅल्यू कुठे चेंज होती, तर ऍक्सेलरेशन चेंज होती. W ची व्हॅल्यू सेम आहे 13 न्यूटन किलो न्यूटन, G 9.81. You are calculating the acceleration. Its value is this plus mu. You know that its value is 0.15, coefficient of friction, and W, that is the 13 Newton. So you are getting the total force required to stop the motion of cylinder 2510 Newton. Force मिळाले की प्रेशर काढणं सोपं आहे. प्रेशर इज इक्वल टू फोर्स अपॉन एरिया. फोर्स माहित आहे आपल्याला, एरिया पुन्हा इनर बोर डायमीटर ने डिवाइड केलं 5 by 4 d square. You are getting this pressure, and such pressure, it is a combination of pressure required to overcome the force to move the piston, and the pressure required to overcome the motion of the cylinder, that is the P2. So this is the addition of P1 and P2. You are getting the value of surge pressure. P1 ची व्हॅल्यू इथे मिळाली पहा तुम्हाला. This would be the P1, and this would be the value of P2. The combination of this, it will be called as a surge pressure to overcome the motion of the piston as well as to overcome the force which will cause the motion of the cylinder. In this way, you are getting the value of the surge pressure, that is a 24.47 bar. Are you getting how to calculate the surge pressure?
Yes, sir.
Okay, write down this. Is it over?
Yes, sir.
Okay. In this in this lecture, we have covered piston velocity as well as force required to move the piston. Right. So these both 2 points which are the remaining from the second chapter, that is the force and velocity calculation for the piston, we have covered during this lecture by using these examples, right? Any any doubt regarding these two examples?
No, sir.
Okay. See, who is remaining to give the attendance? There are total 18 people are there, right? Okay. I think it will be indicated. Okay. निखिल आता जॉईन झाला काय? हॅलो निखिल. Okay, I think this will be the sufficient for the today's lecture. We will stop over here. In next lecture, we will start with a revision as well as some animations to clear the concept of various content of the syllabus. Okay, thank you. We will stop over here.